Good morning. I said good morning. So in the morning, definitely when you're talking about offshore energy, the energy level need to be on the higher side. Okay, just I want to make it very clear because many a time there's a lot of issues we are trying to talk about offshore. And people, many a time they say, why so late? And other important point, what I'll get a frequent question is going to be, the people who started offshore in early 1980s itself, but in India still we are to take up. Yeah, these are the questions. I'll try to answer few of them, and few of them I need to park it at a later time. Okay, and today what I'm trying to talk about, I try to start right from the blue economy, which is what we are trying to talk about today. Because that's a kind of a driving force that this present government is trying to talk about. So the sectors of the blue economy, the marine fishing, biotechnology in the marine space, offshore and deep sea mining, the tourism, shipping, marine construction, but more importantly, what we are trying to talk about is on the offshore renewable energy. When you talk about offshore renewable energy, it's going to encompass both all kind of energy you're going to get it, including offshore solar, offshore wind, offshore solar, the wave, tidal, every energy we're trying to talk about. But prominent as on today is on the offshore wind. So in this particular one, we have a lot of opportunities available. The interdisciplinary skills, R&D, marine spatial planning, the public-private partnership, the center-state cooperation, collaboration with international research institutions. If you try to talk about offshore wind space, every aspect is getting covered here. Interdisciplinary. Please remember, I always say that a wind turbine is an engineering model of the 21st century. Again, I want to repeat, and if I talk about in the 20th century, the electrical power system as an engineering model, with a kind of interconnections and a kind of a power flow, which is going to happen in real time. In 21st century, we will rate the wind turbine as an engineering model. Just imagine why I'm talking about that. If I talk about the blade length today, it has gone up to, each blade is going to have a length of going up to 90 to 120 meters. And if I try to talk about the nacelle, the generator, and every assembly, including the blades, we are going to lift the weight of close around 500 to 600 tons, lift at a height of 200 meters, and make it to rotate. It's not going to stand still. Just imagine, I'm going to lift a weight of more than 500 tons of weight and station at the top of, with a small tower, I'm going to make it for 200 meters and make it to rotate. Please remember, it has to take care of the entire dynamic forces. And if I talk about offshore, the journey is going to still be difficulty because I am going to experience a natural environment, the seashore as you're aware. In addition, we are trying to talk about the tornadoes, the cyclones, every aspect of it. This turbine, I cannot disassemble whenever I have cyclones and I can assemble it back. It's not possible. Once if I assemble it, it's going to be there for 30 years, 25 years, 30 years. That's the kind of engineering model we're trying to talk about in the offshore wind space. So just to give the blue economy today, what we are trying to talk about, we are trying to say the wide range of economic activities. The more focus today is on the ocean energy, including offshore wind, tidal and wave energy, and extraction from oil, the seabed mining, all these things. This of course is not relevant to today discussion, but more focus we are trying to talk about is on the marine renewable energy, offshore solar, offshore wind, tidal, and the ocean thermal energy. So of which, as of now, the VOTEC, to some extent, the experimental stage is already talked about, and very prominent today across the globe is on offshore wind, which is more than 300 gigawatt of installed capacities. So India is blessed with a long coastline of 7,600 kilometers. The potential is high, no doubt. But the main problem is going to be, please remember, when I talk about the offshore wind, the wind need to be steady. I need to have a wind speed of not less than 9 to 10 meters per second and an average. I'm talking about average wind speed. If you talk about European waters, the wind speed is going to range between 9.5 to 10.5. If you talk about Indian waters, if I say in the Gujarat coast, okay, I have typically between 7.5 to 8.5. If I talk about Tamil Nadu coast, I am trying to see in the range around 8 to 8.5. Please remember, the wind has got a peculiarity in it is going to be flowing based on the temporal difference between the water and the land mass. So why I am having, as of now, the potential is getting identified in Gujarat and Tamil Nadu is because I have this kind of a pause is there. This is the pause is going to make you the wind to be flowing high. That's why I am getting the better wind. And similarly, if I talk about here, is because here I have the Sri Lanka and the India pause. So I am getting, this is where the wind is getting generated, I will get a steady wind speed. Every time I would be hearing the people saying that I have a cyclone on the east coast. In a year, at least we'll be having 2 to 3 cyclones coming up. Why can't we have wind turbine there? It's not suitable. I am not going to design a wind turbine for a certain period of time. The wind speed is going up to 50 to 70 meters per second. At that time, I am going to park the wind turbine not to rotate because mechanical stability is not possible. What I do is, the moment the wind speed goes beyond 25 meters per second, I will make the wind turbine to stop. Because it is going to take only the static load part of it, it's not designed for dynamic load beyond 25 meters per second. If I want to design that, I need more steel. The more stability is not cost economic. Presently, we are trying to design the wind turbine. It's going to start rotating at a speed of say at 2.5 meters per second to 3 meters per second. And it's going to achieve its rated power roughly between 9 to 12 meters per second. And the moment it reaches 25 meters per second, it is going to drop its power by 30 meters per second, no generation possible. So when you talk about cyclones will be having a wind speed more than 30 to 40 meters per second is not suitable for harnessing wind. That's why even if you see, I have very, very less potential on the east coast. Except here, because of land mass I'm going to get, but not here. So here also not much of a things. So that's how I would put it very clearly. Please remember, just because I have the coast doesn't mean to say that I can have offshore wind. So this is a kind of a potential mapping we have it. Okay, we identified zone A to zone H in Gujarat. Similarly, zone A to zone H in Tamil Nadu. And there are certain areas which have been demarcated by Ministry of Defence as sensitive. So we are neglected, we are removed as of today. Till we are having a complete safety is going to come up. The sensitivity is going to go off. So we are going to have in Gujarat the zone C, the zone G, H. This is as of now it is blocked. We are not trying to develop as on today. And similarly, the zone H in Tamil Nadu is being blocked for MOD. And the remaining, I have potential ranging. Again, we make an assumption at 3 megawatt per square kilometer is there, and an average you can develop. But again, with the technology, this number can change. So it's going to be between 2.5 megawatts going up to 5 megawatts. If you talk about European waters, we are having talk about it typically 5 megawatt per square kilometers. It all depends upon the turbine design and what kind of energy extraction you're going to have it. Every other factor is going to depend on. So this is the kind of a thing what have been already demarcated, and further we are doing the studies, and we try to have each blocks. There are some more sub blocks we are going to create it. So as of today, you have heard we already released a strategy paper because the government of India has made a clear target of 30 gigawatts of development by 2030. So we want to have 30 gigawatt of offshore wind by 2030, for which the government has come out with a strategy paper, and we are trying to talk about this. Remember, there is no one fit size for everyone. So in order to take care of it, we are having different models of development. The model one where we have already data, so we are going to go for the turbine directly. As of today, we are having a zone B2 in Gujarat. We have a data of the wind. I'll come to later. Wind, the geophysical, geotechnical, and EA studies have been done for that. So we are going to come on that. and we have model 2A, where we are trying to talk about making the developers to do the studies and surveys, and then after that we are going to come for the tendering purpose. Then we have model 3, where we are trying to talk about the open access, where any developer is free to identify any piece of the offshore where he can initiate the statistical survey. So we are going, that National Institute of Wind Energy has been designated as a one-stop shop for all the clearances. So just to give a brief, as of today we have in the model 1, zone B3 has been identified, where we have all the data. There is a Taluk is Jafrabad and Amreli district in Gujarat. This is a location where we have placed our LiDAR, and the water depth typically around 15 meters, and distance from the coast is around 23 kilometers, and nearest village is Pipo, and we also have the port, nearest port is the Pipo, and also Jafrabad is a small Boyandam port, we can have it. Then we have all the details have been given, and the CSN zone 4 is going to come up as per a 2011 notification is offshore development. What prevents in developing as of today? As of today, if you try to estimate the present class of wind turbine available in the market, the cost of generation would not be less than 11 to 12 rupees. So 11 to 12 rupees is the economic factor which is going to be a determining factor today, and that's precisely why the government of India, we are trying to talk about to arrange the viability gap funding, because as a consumer, as a discom, he is not ready to buy the power beyond 3 rupees 50 paise. So we need to bridge the gap between 3 rupees 50 paise to the actual cost of generation from the offshore. So that's why, otherwise, if the consumers are prepared to spend the money 11 rupees or 12 rupees, definitely we can have it offshore too. But please remember one important part. In fact, many a time I am getting a question talking about solar started at 21 rupees, and it was 17 rupees, 15 rupees. Still, the government has given a kind of a guidelines to move forward. Please remember, the solar is typically, even if you talk about distributed energy sources, the distributed, true distributed is going to be the solar, because I can have 1 kilowatt modules. The modules are going to be 200 watts to 500 watts to 700 watts. But if I talk about a wind turbine, a single wind turbine of the offshore class, as on today, is ranging from 10 megawatts going up to 15 megawatts. And I cannot install only one wind turbine in the offshore. It's not economical. So if I want to develop, I have to develop a minimum scale of 500 megawatts. That's going to be the economic of scale for operation, because I need to bring the offshore vessels, and installations, every aspect of it is going to be more expensive. If we are having a less than 100 megawatt as a demonstration, the cost of generation is going to go beyond 15 to 20 rupees. That's how the economic scale is going. That's precisely why when you try to talk about target, we want to set a target of 30 gigawatts so that we have a clear pipeline for all kind of manufacturing, and the R&D, and the surveys, everything is going to be there. That's going to be the economic of scale. So that's the difference between the other distributed sources to the offshore. So this is the kind of a development we are trying to talk about for a model 2 and model 3. We try to identify different subblocks. Each subblocks can develop ranging between say 300 megawatts going up to 500 to 800 megawatts, depending upon the spacing they want to have. So this is the kind of a development we are trying to talk about. So please let me know when I'm going to stop. Okay, I need to give at least 10 minutes for the discussion. And this is for the Tamil Nadu, where we have the B blocks and C blocks and F block has been identified. The G blocks, yes, there are some things are there, but going down, here the water depth is going to be more than 50 meters, 35 to 40 meters, and many times it's going to go beyond 50 meters. As of today, anything beyond 30 to 40 meters, again not economical. If you're going to 50 meters, we are going for floating. If you're going for floating cost is going to be much higher. Because this is the one area, because since I'm coming to IT research talk, I need to talk about what are the research being done right now and what are the opportunities available. And first and foremost, any wind turbine, when you are trying to design, I need to test the wind turbine. The prototype model to be tested, and that's going to be an important aspect whenever you try to talk about any wind turbine. Please remember, the wind turbine is a one industry right from day one. The safety and quality was never compromised. And without any turbine, it has to be tested completely, and these test results will be compared along with the design of the wind turbine, and the third party certification body is going to give, not the person who is going to test it. Please remember, the OEM is going to manufacture turbine, a separate testing body, independent testing body is going to test this turbine, and independent certification body is going to certify that this turbine is suitable to be operated and it can have a design life of 20 years. So that's the kind of a thing right from day one, because the wind turbine, as I told you, is an engineering model. At the same time, if it is not properly designed, is properly not taken care of, it is going to be catastrophic. The accidents is very, very difficult. And I can tell you, we are very proud to say, India is, in addition to certification, we do have other regular checks and balances. And as of today, I can say with confidence and with a proud, India is the one country where the wind turbine accidents is the lowest in the world. Because we never compromise the quality before coming into the country, and more, please remember 70% to 80% is make in India for wind turbine. And we insist that the make in India is there, and they will be having a quality checks, and every aspect will be taken care of, including indigenizing the standards and also coming with the additional regulations. So in this regard, we already started to talk about the test center. This test center is going to take 5 minutes. This test center is unique in the world, where I can get the entire offshore scenario on the narrow strip of land. This is the Dhanushkodi strip, okay, ranging from say around 1 kilometer here, going up to few meters here. So already we got a land of close to 75 acres. The beauty of this particular one, what we are trying to concentrate is, we'll be having a 2 wind turbine who is going to take care of the requirement of Rameshwaram. We talk about reading of Rameshwaram. And other one is, we are trying to have these 2 turbines to be of testing. We are trying to create the universal test base. So we are trying to talk about the foundation is going to be laid, which can withstand the foundation load to an extent of 20 megawatt wind turbines. So I can test the 20 megawatt wind turbine. And moving forward, 50 days back, we had a meeting with the NIS officials. They said, have one more foundation which can take care of, even when the wind turbine goes to a height of 400 to 500 meters. Please create it, because this is going to be a unique one. This is the area we are trying to talk about, but critical challenge is going to be how to design the universal foundations to take care of these dynamic loads. So this is another one, meteorological studies we already carried out for Gujarat in one block, and these are the LiDAR, the wave sensors, the current profile sensors, everything. And we have, this is the LiDAR facility, and also we have the sensors are here, and this is the LiDAR, we are going to measure up to 200 meters. And this is the radar gauge measurements, the tide level, we measure the tide also, and this is a low tide is going to minus 2 meters to plus 2 meters. And presently, now we are exploring to go for a floating LiDARs for Tamil Nadu, because the fixed LiDAR, when we talk about fixed platform, is going to be expensive. So we are trying to, this is the one area, as of today, we need to import, but if the design is made available, NIOT is very keen to develop it, and some of the IIT research, if somebody is interested, please partner, come out with a floating voice so that we can mount this particular to measure the wind speed and the other oceanic studies. And geophysical, we are completed for, I think, this is the one area we also worked on, and we are trying to talk about Tamil Nadu. And and this is the area what we are talking about, bathymetry, barometer, subwater profile, the side scanner. And this is the different, of course, some of the sites I'll try to share it, which is not going to be confidential. Geotechnical, we are completed in Gujarat and also the Tamil Nadu coast, 3 locations we done it. So we went up to a depth of 60 to 70 meters to have, what's the kind I'm talking about, below the earth surface, we went up to 60 to 70 meters to understand what kind of a soil strength is there at a different levels. And this is the one environmental area we are trying to work on, EA assessment, that's going to be important. Okay, MSP and MEA, as of today, we are working it on. We are trying to see how best move forward on this particular aspect of it. Thank you.